Welcome, welcome. Welcome, welcome. It's been a while since welcome again. It's been a while since we used our voice. But today we're gonna start with chapter 14. Yep. So we were able to do a lot. Oh shoot. Well, I've not learned about setting up, uh, static IP address. That was good to learn. It wasn't something important. It was something important to learn, and since I'll be exposing, not really exposing, but I'll be using like IP addresses a lot, in these studies, and it's important it's important to have that figured out. Let's see here. Um, okay. All right. Everything seems to be good. Let me check my voice. See that everything is good and working well. Check my voice. See that everything is good.
I added a team of play.
All right. All right. Okay. Okay. All right now it's good. Right now it's good. It's good. It's good. It's good. All right. Okay. Okay. And it's important to it's important to have that figured out. All right. All right. It's sounding good. Let's return to this. So, oh, welcome again. Um, welcome to the study. We're not gonna be doing Pomodoro style today. We haven't started doing that yet, so we're just gonna do our normal one. All right. Let's just start with chapter 14 then. Okay, so chapter 14 is about understanding and inspecting wireless networks. Um, I don't know if I will have wireless. I'm connected to wired right now, but we're gonna see how that will work for us. There we go. Okay, let's get into this. Right, it's understanding. Okay, so the ability to scan for and connect to other scan ability to scan for and connect to other network devices from your system is crucial to becoming a successful hacker. And with wireless technologies like Wi-Fi, IEEE 802.11, and Bluetooth being the standard, finding and controlling Wi-Fi and Bluetooth connection is key. If someone can hack a wireless connection, they can gain entry to a device and access to confidential information. The first step, of course, is to learn how to find these devices. In chapter 3, we look at some basic networking commands in Linux, including some of the fundamentals of wireless networking, with promise of more wireless networking to come in chapter 14. As promised, here we examine two of the most common wireless technologies in Linux, Wi-Fi, and Bluetooth. Okay. Wi-Fi networks. We'll start with Wi-Fi in this section. I'll show you how to find, examine, and connect to Wi-Fi access points. Before doing so, let's spend a little bit of time going over basics Wi-Fi terms and technologies to help you better understand the output from a lot of the queries we'll make in this chapter. AP, access point. This is the device wireless users connect to for internet access. ESSID, extended service set identifier. This is the same as the SSID which we discussed in chapter 3, but it can be used for multiple APs in a wireless LAN, access points in a wireless lanes. BSSID, basic service set identifier. This is the unique identifier of each access point, and it is the same as the MAC address of the device. SSID, service set identifier. This is the name of the network. Channels. Wi-Fi can operate on any one of the 14 channels, 1 to 14. In the United States, Wi-Fi is limited to channels 1 to 11. Power. The closer you are to the Wi-Fi access points, the closer you are to access points, to Wi-Fi access point, the greater the power and the easier the connection is to crack. Nice. All right, security. This is the security protocol used in the Wi-Fi AP that is being read from. There are three primary security protocols for Wi-Fi. The original, wired equivalent privacy, WEP, was badly flawed and easily cracked. Yeah, the replacement, Wi-Fi protected access, WPA, was a bit more secured. Finally, WPA2 PSK, which is much more secure and uses a pre-shared key, PSK, that all users share, is now used by nearly all Wi-Fi access points enterprises, except enterprise Wi-Fi. Modes. Wi-Fi can operate in one of three modes: managed, master, or monitored. You'll learn what these modes mean in the following section. Wireless range. In the United States, a Wi-Fi access point must legally broadcast its signal at an upper limit of 0.5 watts. At this power, it has a normal range of about 300 feet, 100 meters. High gain antennas can extend this range as much as 20 miles. So I for my Wi-Fi in my house, I want to increase the range. It's not going to increase the speed per se, but it will help with the speed. Like if you can increase the range, like someone who is, let's say, at the porch. If I have my a access points like in the back, if I put like antennas, around the house, and also like I believe also access points. Well, I'll use antennas in this case because I can't move. I can't really. It's a little bit difficult for me to use access points because there's no way to kind of like move. What are they called? Like there's no way for me to move. I mean to like wire the Ethernet ports. I mean the Ethernet cables or patch cables inside the house. So, frequency. Wi-Fi is designed to operate on 2.4 gigahertz and 5 gigahertz. Modern Wi-Fi APs and wireless networks cards often use both. Basic wireless commands. In chapter 3, you are introduced to the basic Linux networking command, ifconfig, which lists each activated network interface on your system, along with some basic statics, including most importantly the IP address of each interfaces. Let's take another look at your result from running ifconfig and focus on wireless connection at this time. Okay, so the Wi-Fi interface here is shown as WLNO. In Kali Linux, Wi-Fi interfaces are usually designated as WLNX, with X representing the number of that interface. In other words, the first Wi-Fi adapter on your system will be labeled WLAN 0, the second WLAN 1, and so on, with if you just want to see your Wi-Fi interfaces and their statics, Linux has a specific command that's similar to ifconfig, but dedicated to wireless. That command is iwconfig. When you enter it, only wireless connect interfaces and their key data are displayed. I do not have a wireless interface on my computer, so probably not gonna show up. But let's try anyways, right? Let me put this up. Oh, why is it over here? Did it? For security reasons first. All right, exactly. Um, I have no wireless extensions or anything, so there's nothing to show for, especially for this chapter. But we can still learn something from me. Okay. In Kali Linux, here we just see the wireless interfaces, also known as network cards, and key data about them, including the wireless standard utilized, whether the ESSID is off, and the mode. The mode has three settings: managed, which means it's ready to join or has joined an AP; master, which means it is ready to act as or already is an AP; and monitor, which we'll discuss a little in the chapter. We can also see whether any client has associated with it and what its transmit power is. Among other things, you can tell from this example that WLAN 0 is the mode required to connect to the Wi-Fi network, but it's not connected to any yet. We will revisit this command again once the wireless interface is connected to the Wi-Fi network. If you're not certain which Wi-Fi access points you want to connect to, you can see all the wireless access points your network card can reach using the iwlist command. You can perform multiple action with the iwlist. For our purposes, we use to scan action received off it. Note that with standard antenna, your range will be 20 feet, but this can be extended with an expensive high gain antenna. So I don't have antennas on my what's it called, on my motherboards, so I don't even have like, I can't even add on antennas on it. But in the future, I'll probably have something that has an antenna, buy a Wi-Fi, even a Wi-Fi chip. Let me see if I can add a Wi-Fi chip though. I mean, I don't think I do. Yeah, I don't think that I do. But even so, like, I can look up the motherboards on the manufacturer's website and see if it does, but I'm sure it does not. So let's see. WLAN scan IW list. Let's try that first. Yeah, I could not find anything. Okay. All right. Okay, so the output from this command should include all Wi-Fi access points within the range of your wireless interface. along with the key data about each AP, such as the MAC address of the AP, the channel and frequency it is operating on, its quality, its signal level, with its encryption key is enabled, and its ESSID. You will need the MAC address of the targeted AP, the MAC address of a client, another wireless network card, and the channel the AP is operating on in order to perform any kind of hacking. So it is valuable information. We okay. All right. Let's oops. Okay. Let's let's move over here. And then let's see cat on what is it? Wi-Fi. Oh, cat to Wi-Fi hack.txt. Okay, so in order to hack a Wi-Fi, you will need the following, right? One. So we'll need to know the MAC address, aka BSSID. Oh, BSS. Oh, I can't move. BSSID. No, I can't do that either. BSSID. Two. You will need the MAC address of the target, the MAC address of the client. Oh, MAC address of a client. You need MAC address of the target. MAC address of the client. Three. You will need okay. Three. Channel. Okay, the channel. The AP is operating on. Okay. All right. Oh, what? Bro, it ain't. Okay. Cat to. Three. Channel the AP is operating on. All right. Let's see. Nice. That's just the basic of how to create a text, and I could also open this in right over there, and then I could make MAC address of the target AP of the client AP. All right, and then I could do right out, enter, and then exit. Look at that, we're becoming proficient in Linux. All right, okay, let's clear that out. Too much junk. Oh my gosh. Okay, I like that. I like that. We can do that now. No, we can do that now. It's fun now. All right. Okay, what's next? Okay. Another command that is very useful in managing your Wi-Fi connection is NMSCLI, or the Network Manager Command Line Interface. The Linux daemon that provides a high-level interface for the network interfaces, including the wireless ones, is known as the Network Manager. Generally, Linux users are familiar with this daemon from its graphical user interface (GUI), but it can also be used from the command line. The NMCLI command can be used to view the Wi-Fi APs near you and their key data, as we did with the IW list, but this command gives you a little bit more information. We use it in the format NMCL dev network type, where dev is short for devices and the type in this case is Wi-Fi, like so. Okay. Let me write that down on our board. Now I lost. My gosh. I lost some of my small markers. It's okay, I can just use the so the process but first let's see what that does. See. Okay. I'm going to. Okay. So what we need, we're going to write down is the IW config. Sure, it's already on here. Huh? It's not. And then we have the, what's the command? NMCLI. NMCLI. Let me try. Let me do a test to that. NMCLI. MC. Oh, I knew it should. Oh, no. Well, that's just the DNS server anyways. Okay. So this one, it shows everything. It shows all of them. Holy. That's a lot of info. That is a lot of info, I say. Too much info. Interface, servers. That's the end. Oh my gosh. So then we can do, and then we can do like NM, oops, consults, NMCLI device Wi-Fi. Well, that didn't. All right, I think it might not work like that. You know. No more, maybe. I mean, this, well, there's no Wi-Fi, so I guess that could be why. But yeah, give me 1 second. Let me write this down. And then here you do. was it? Mm. Network type. Wi-Fi. Okay, we got it wrote down. Go on over there so we can see our border a little bit more. Okay, so we got that wrote down. Um, okay. Let's check on. Well, no. Let's actually read what we got from this. Because I got something. My command. I couldn't do the device type. So, in addition to displaying the Wi-Fi APs. Oh, I was still up there. No, I'm not there yet. Yeah. Okay. Let's see all these Wi-Fi APs. Wi-Fi like so. So, in addition to displaying the Wi-Fi APs within range, let me see if dev Wi-Fi. Yeah, it's even the same thing on here too. I don't know why I don't have Wi-Fi. That could be why. In addition to displaying the Wi-Fi APs within the range, and what if I do Ethernet? Dev type and I'm slide dev. Or do I have to put it together? Ethernet. Okay. And MCLI. Okay. Let's read it. An MCLI. There's no manual? An MCLI question mark. Okay. An MCLI help. Okay, there we go. All right, this shows us much more than that we need, to understand how to use it. Okay, NMCLI option objects command. Usage options is to the -A ask, -C color auto yes no, -E escalate. Ask for missing parameters. Oh, whether to use colors in output. -E escape yes no, escape columns. -F specify fields to output. -G shortcut for -M tubular -title. Oh my gosh. -H for help. -M output mode, overview mode, pretty output, allow displaying password. No. Terse output, show program version. Okay. G, general. Networks manages general status and operation. Overall networking control. Networking manages radio switches. Network managers connections. Device managed by network manager. Network manager secrets agent or Paul kit agent. Network managers changes. Let me do that. device C. Okay, let me do that. Nah, 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 nah. C. All right. Wired connection. Ethernet. E01. So why isn't it allowing me to, type that like Ethernet? Does it have to be like close to dev then dash Ethernet? Okay. So it shows that for when using the DE arguments, it comes back, it shows you like Ethernet and Ethernet 1, show Ethernet connected and wired connection 1. It shows that, but well, I guess it cannot show Wi-Fi. No, though. When I try to get the like output for the, maybe I just do NMCLI, let's do Ethernet. No, maybe DE Ethernet. That doesn't work. Those arguments do not work. Oh shoot. All right. UUID. Let's do a little bit of research, shall we? Network UUID. Find the UUID. So universal unique identifier unit designed to be a unique identifier for objects in computer system. UUID is this designed to be large enough that any randomly generated UUID will let's see. For network interfaces can be generated using the following command. Well, I know how to get it now. Okay, those are like questions from 2013. I'm not gonna bother myself with those. Let's not go over there. Okay, so from the one of the commands that I just put in the command nmcli, so it shows me I got Ethernet. It shows what time I opened it. Maybe a PV4 default. That it shows my what's it called? My static IP that I set up. Router matrix, router default. It shows my IPv6 and its routing. And then it shows the LO, which loopback, which I do not know what it is yet. I mean, I'm probably supposed to know what it is. Maybe I just forgot. And then DNS configuration, which I just connected to the Google DNS servers. Okay, use NMCLI device show to get complete information about known devices, and NMCLI connection show to get. Maybe this is what we needed to know. Yeah. Maybe this is what we needed to know. Devices and NMCLI connection show. Okay, NMCLI device show and NMCLI connection show. Okay, let's do that. NMCLI device show. Okay, it shows way more information. Yeah. Destination, look back. Oh, that's the end of it. You see IPv6, IPv4. The other one was connection show wired UUID. Okay. Um, I don't like showing any of this yet, so because I do not know which is safe to show. I mean, right now I think of the static IP address because that I can change that at any time I want to. Oh, we can also use an MCLI. Okay. In addition to displaying the Wi-Fi APs within range and key data about them, including the SSID, the mode, the channel, the rate of transfer, the signal strength, and the security protocols enabled on device, an MCLI can be used to connect to APs. An MCLI device connect AP SSID password, AP password. Okay, so based on the results from our first excuse me. So based on our results from our first command, we know there's an AP with the SSID of hackers arise. We also know it was WPA1, WPA2 security. This means that the AP is capable of using both the old WP1 and the newer WPA2, which means we will have to provide the password to connect to the network. Fortunately, as it's our AP, we know the password is 1234578, so we can enter the following: NMCLI, Wi-Fi connect, hackers are right, and password. This activated with the okay. Try this on a network you know, and then when you have successfully connected to the AP wireless AP, run iW config again to see what has changed. Here are my okay. So if you want to connect to a Wi-Fi, without using the GUI, you just do it like that. Okay, that's good. I probably don't need to do that. So note that now iW config has indicated that the these hackers arise and that the AP is operating on a frequency of 2.45. In Wi-Fi network, it is possible for multiple APs to all be part of the same network. So there are maybe many APs that make up the hackers arise network. The MAC addresses is, as you might expect, the MAC address of AP I am connected to, what type of security a Wi-Fi network uses, whether it is running on 2.4 gigahertz or 5 gigahertz, what its ESSID is, and what the AP's MAC address is. All critical pieces of information that are necessary for the Wi-Fi hacking. Now that you know the basic commands, let's get into some hacking. Okay. Let me see. All right. Okay, Wi-Fi recon with air cracking. All right, let's get into this. Let's get it with some hacking and shit. Okay. One of the most popular exploits for new hackers to try is cracking Wi-Fi access points. As mentioned, before you can even consider hacking a Wi-Fi AP, you need the MAC address of the target's AP, BSSID, the MAC address of a client, and the channel that AP is operating on. Oh, also the channel that the AP is operating on. Okay, so we can do. Let me do that. Zoom in a little bit. Okay. Let's go to documents. Let's go to documents. Let's open that so we know what we need. I don't know how to do this yet, but the new tab. No. How do I? Shit. How do I change this to have its own session? New tab from present. Let's say horizontal terminal. Right. Okay. All right. I don't mind that. That also works. Now, although I would prefer if it was vertical. So from new tab, put as a vertical. Vertical. Okay. What are some? All right. We'll learn that. Let's here. Let's put on documents. CD documents. Okay. Well, no. Let's here cat what is it called? Wi-Fi hacking .txt. Okay, looks like we have to be in documents first. Documents and then okay, all right. Now we're here. We're still moving slowly, but we're gonna get there, Okay. All right, we stop it there. Okay, so let's get started. Yeah. Jambo. Go bien. Okay. Okay, blah 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 blah. So we need the MAC address of the target, MAC address of the client IP, and channel the IP is operating on. Okay. All right. We can get all that information and more using the tools of air cracking suite. I've mentioned this suite of air cracking tools of air cracking suites. I've mentioned a few times before, and now it's time to actually use it. This suite of tools This suite of tools is included in every version of Kali, so you don't need to download or install anything. To use these tools effectively, you first need to put your wireless network card into monitor mode, so that I do not have a wireless. Right. I don't have a wireless networking card. Man. Um yeah. Okay. I can put the tools effectively. First, need to put your wireless networking mode into mode so that the card can be um so that the card can see all the traffic passing its way. Normally, a network card captures only traffic destined specifically for that card. Monitor mode is similar to promiscuous mode on wired network cards. To put your wireless network card in monitor mode, use the air monitoring commands from Air Cracking Suite. The syntax of this command is simple. Okay, so we do. Um, I'll be back in a second. Okay, air monitoring. Um, start, stop, and restart interface. Run it as a roots. All right. So it gotta be roots. So root. No, not roots. Sudo. Okay. Air morning stuff. Usage. Hold up. Hold up. So do we like? I don't know why I stop enter like that. So if you want to put your wireless network card designated WLAN O into monitor mode, you want into the following: Airmong start WLAN O, but I do not have um, start WLAN O. I do not have that. I don't have it. Uh, okay, let's see. Found one process that could. Oh, requested WLAN O does not exist. I knew that was gonna happen. So found one process that could cause trouble. Killed them using airmong check kill before putting a card in monitor mode. They will interfere by changing channels and sometimes putting the interface back in mode. Oh, the PID. That's the ID that you have when you're looking at the tasks. Like if I pull up top over here, oh, not Rob, but top. That would be the PID of the thing. But okay. Okay. So we don't have that. So that's another thing that we can do on this. So first was chapter 12 we can do because we don't have a Raspberry Pi yet. And now chapter 13 we can do it. Oh, chapter 14 per se. We can't do it because we do not have a Wi-Fi card. That's hard. That's difficult. I'll try to do it on my computer, on my laptop. So the stop and restart commands respectively stop monitor mode and restart monitor mode if you can run into trouble. If you run into trouble. With your wireless card in monitor mode, you can access all the wireless traffic passing by you within the range of your wireless networking adapter and antenna. Note that AirMon will remain your wireless interface. Not, mine has been renamed to WNO Mon, through yours may be different, though yours may be different. Make certain to note that the new designated name of your wireless because you'll need that information in the next step. Now we'll use another tool from the air cracking suite to find key data from the wireless traffic. The error dumping command captures and displays the key data from broadcasting APs and any clients connected to those APs or within the vicinity. The syntax here is straightforward. Simply plug in Airmon Inc. Followed by the interface name you get from running Airmon Inc. just now. When you issue this command, your wireless cards will pick up any crucial information listed next from all the wireless traffics or the AP nearby. Power the strength of the signal, ink the encryption, stack the data through rates, throughput rate, CH the channel AP is operating on, ESSID. Shoot, I want to buy a yeah, I think I should probably buy one. Let me see. What is it called again? It's called ThinkPad. Oh no. I think I need a ThinkPad. I did. What the heck? Gee. What is this? Hold up. Is it that good? This laptop is $15,000. HP ZBook Fury G1i 18 mobile workstation with 3-year warranty and Wolf Pro Security. Did they meant to make it? Yeah, it's $14,000, $8,000. What? No way. No way. I know I'm already lost. 4,000. What is that? Large, powerful mobile workstation designed for professional, creative, and technical tasks like 8K video. Why? What? I thought it was like some hardcore, like, hacking tool. That's, bruh. Nah. Nah, but I need to buy a ThinkPad. I'm gonna give me a ThinkPad. Uh, Chapter 17. We're not over there. Okay. Okay. Air dumping command followed by interface running mrun when you use this command. Okay. All right. So we can't you do this command yet, but I will write it down, and it's something that we will have to do once we get our laptop here. Hold on. Yeah, I could SSH into a laptop and then. Oops. Oh, dang it. Hmm. Okay. Anyways, let's go on with this. Let's finish one chapter today. This chapter is a lot. A lot more than I expected. Okay. All right. Note that the air tapping splits the output screen into an upper and lower portion. The upper portion has information on the broadcasting APs, including the BSSID, the power of the AP, how many beacons frames have been detected, the data throughput rate, how many packets have traversed the wireless card, the channel, the theoretical throughput limit, the encryption protocol, the cipher used for encryption, the authentication type, and the ESSID, commonly referred to as SSID. In the client portion, the output tells us that the one client is not associated, meaning it has been detected but is not connected to any AP, and that another is associated with the station, meaning it's connected to the AP at the address. Now you have all the information you need to crack the AP. Although it's beyond the scope of this book, to crack the wireless AP, you need the client MAC address, the AP MAC address, and the channel that is operating on, and password list. So to crack the Wi-Fi password, you will open 3 terminals. In the first terminal, you could enter commands similar to the following, filling in the client and AP MAC address in the channel. This command captures all the packet traversing the AP on channel 10 using the C option. In another terminal, you could use the airplane command to knock off deauthenticate anyone connected to the AP and force them to reauthenticate to the AP as shown next. When they authenticate, you can capture the hash of their password that is exchanged in the WAP to KPSK 4-way handshake. The password hash will appear in the upper right corner of the air dump terminal. Finally, in the final terminal, you can use the password list to find the password in the captured hash as shown here. Wait, so this tells you what you can do, but it won't tell you, it won't go deep into it, because I'm sure like with WPA2 PSK, it should have some like it should have some it should have some security measurements. I'm sure it won't be that easy to just hack into it or hack into anything. Okay, detecting and connecting to Bluetooth. These days, nearly every gadget, mobile device, and systems has Bluetooth built in, including our computers, smartphones, iPods, tablets, speakers, game controllers, keyboards, and many other devices. Being able to hack Bluetooth can lead to the compromise of any information on the device, control of the device, and the ability to send unwanted info to and from the device, among other things. So, can I hack my controller? If I hack my controller, what will that leave me with? Okay, let's see. So here we can do Bluetooth. Okay, there we go. Let's see how Bluetooth work. You need to understand how it works and an in-depth understanding of Bluetooth beyond the scope of this book, but I will give you some basic knowledge that will help you scan for and connect to Bluetooth devices in preparation for hacking them. Bluetooth is a universal protocol for low power, near field communication operating at 2.4 and 2.4 to 2.48 gigahertz using spread spectrum, frequency hopping at 1600 hops per second. This frequency hopping is a security measure. It was developed in 1994 by Ericsson Corp of Sweden and named after the 10th century Danish king Harald Bluetooth. Note that Sweden and Denmark were a single country in the 10th century. The Bluetooth specification has a minimum range of 10 meters, but there is no limit to the upper range manufacturers may implement on their devices. Many devices have range as large as 100 meters. With special antennas, that range can be extended even further. Connecting two Bluetooth devices is referred to as pairing. Pretty much any two Bluetooth devices can connect to each other, but they can pair only if they are in discoverable mode. A Bluetooth device in discoverable mode transmits the following information: name, class, list of services, and technical information. Okay, let's write that down. So I'm just gonna now write anything in here and then just I don't know why I wrote it like that. Okay, so a Bluetooth device in discoverable mode transmits the following. Transmits the following info. I'm just gonna do one. Name 2, class 3, list of services, and 4, technical info. Okay. When the two devices pair, they exchange a secret or link key. Each stores the link key so it can identify the other in future pairing. For devices has a unique 48-bit identifier, a MAC-like address, and usually manufactured a sign name. These will be used for pieces of data when we want to identify and access it. Okay, so every device has a unique 48-bit identifier and usually okay. A secret link key. That's my bullet point. All right. Bluetooth scanning and renaissance. Okay, Linux has an implementation of the Bluetooth protocol stack called BlueZ that will use to scan for Bluetooth signals. Most Linux distributions, including Kali Linux, has it installed by default. If yours doesn't, you can usually find it in your repository using the following command. So how do I switch? Oh no, not that, man. What's this one, brother? What if I close it? What do I? Like, do I have to click on here to go to it? What if I do this? Um, maybe Alt Tab. Okay. Let me see. What's that? No, it doesn't work. Anyways, we can use the bluesy. What's that? Oh, command found. Um, okay. Should have been installed. Let's see. Okay. Oops. Bluesy. We don't have that. Okay. Oh, maybe it's. Yeah, looks like we got it. Yeah, I think we got it. Okay. We just can't find it. Yeah. Bluesy. Has a number of simple tools we can use to manage and scan Bluetooth devices, including the following: HCI config. This tool operates very similar to if config in Linux. Hold on. There are some things that I gotta write down first. Git list, so scan. Line, airmon. Okay. Yeah, on the second locate. So what we have is airmon. Air monitor. That. No. We're down. Red. We got the touch. Mod. got any more arrow down? Arrow It's a lot of commands. A lot of commands. I will have like commands. Well, I should put it like in sections, in where, or even I should put it as in notes on the Linux thing documents. But like in where I have um let's say if I want to talk or study hacking, it's hacking specific thing, I'll have Bluetooth commands. It's what's it, tools and its commands that I can use. Wi-Fi tools and its command that I can use. That tools and its command that I can use. Yeah, it's a lot. It's a lot. Learning the Linux way or the Linux commands and everything else. It's not simple. I can't say that it's simple. But especially for what you're using it for. If you're using it for some easy things, it's just gonna be those easy things that you need to know. But further than that, if you want to move in, like if you want to do it advance, if you want to advance in that, you gotta do it something different. But okay, let's do our last not last. We're not there yet. We are not there yet. That's okay. Make sure that we save that. It's not on the cloud, so it doesn't have autosave. I don't know if we can implement that to have a to autosave our notes. But it does not. Let's see. Or we only just have sessions. Okay. Anyways, we'll be down here. How Bluetooth works. Already read that. We know that. So sudo apt installed. BlueS, but we cannot do that. But from after I checked, it looks like we already have it. So we're as you can see, I'm already losing. I'm getting hungry. I want to take a break. Yeah, I haven't taken a break, so it's just 1 hour session. If I config, this tool operates very similarly to if config in Linux, but for Bluetooth devices, as you can see listing. This inquiry tool can provide right here. This inquiry tool can provide us with device name, device ID, device class, and device clock information, which enables the device to work synchronously. HRDump, this tool enables us to sniff the Bluetooth communication, meaning we can capture data, send over the Bluetooth signal. The first scanning and reconnaissance step with Bluetooth is to check whether the Bluetooth adapter on our system we're using it recognized and enable. We can use it for other devices. We can do this with the built-in Bluetooth dual HCI config. Okay. So again, HCI config. Well, HCI config. It looks like we do not have a Bluetooth bus. Oh my gosh. I got that. I got none of them. This PC that we built, it does not have a lot of things. So it looks like it. I mean, I could probably add Bluetooth on it, but I was sure it has Bluetooth. I was positive that it has Bluetooth on it. How about we? Yeah, I ain't trying to do that right now. Let's just go and check. Okay. Nope, we do not. It does not look like we do. Devices. Devices. Couldn't connect on this window. Turn on device. How do I even turn on Bluetooth if I can't see it? How can I turn it on if I don't have it? You know, I don't have it. So, yeah. We don't have Wi-Fi. We don't have Bluetooth. We need a laptop. We need a laptop. Normally, people will do something like this on a laptop, but like I'm using my desktop. So, boo-hoo. But no, that's not possible. Although I was thinking I could probably SSH. Oh yeah. Yeah. I believe my Proxmox server, it has a Bluetooth. It has Bluetooth. Yeah. Yeah, I believe it does. It probably has Bluetooth on it. So I will work on that with that to test our Bluetooth and Ethernet hacking. But the only thing about it is like I have the VM, like I put the VM on the server, and with my current knowledge right now, I have to hop on the server and then turn on the VM. But if I could like have the VM running in background and then SSH into it or some other ways to connect into it, that would be nice. But that's another mess for another day. You know what I'm saying? We're here to finish this book. As you can see, my Bluetooth adapter is recognizing with a MAC address of 10 blah blah blah. This adapter has been named SCIO. The next step is to check that the connection is enabled, which you can do. We can also do with HCI config by providing the name and the app command. If the command runs successfully, we should see no outputs, just a new prompt. Good, HCIO is up and ready. Let's put it to work. Scanning for Bluetooth devices with HCI tool. Okay. Now that we know our adapter is up, we can use another tool in Bluetooth Stride called SGI tool, which is used to scan for the other Bluetooth devices within range. Let's first use the scanning function of this tool to look for Bluetooth devices that are sending out their discover beacons, meaning they're in discovery mode with the simple scan command shown in listing 14-2. As you can see on my system, HDI tool found two devices, Android BT and SCS 115. Yours likely provides you with different outputs depending on what devices you have around. For testing purposes, try putting your phone or other Bluetooth devices in discovery mode and see if it gets picked up. by the scan. Now let's gather information about detected devices with the inquiry function inquiry. This gives us the MAC addresses of the devices, the clock offset, and the class of the device. This class it indicates that the type of Bluetooth devices you found. You can look up the code and see what type of device it is by going to Bluetooth SIG sites. Okay, the tool is HCI tool is a powerful command line interface to Bluetooth stack that can do many things. Help with some of the commands you can use. That's a lot. Many Bluetooth hacking tools you'll see around simply use the commands in a script, and you can easily create your own tool by using these commands in your bash or Python script. We'll look into scripting in chapter 17. Okay, scanning for services with the SD pool. Service discovery protocol is a Bluetooth protocol for searching for Bluetooth services. Bluetooth is suite of services, and helpfully, Bluesy provides the SDP tool for browsing a device for services and it provides. It also important to note that the device does not have to be in discovery mode to be scanned. Oh, okay. To be scanned. Okay. Here we can see that the SDP tool was able to pull information on all the services this device is capable of using. Particularly, we see that this device supports ATT protocol, which is the low energy attribute protocol. This provides us more clues as to what the device is and potentially avenues the interface with this version. Seeing whether the devices are reachable with 12 I2 ping, L2 ping. Once we've gathered the MAC addresses, all the nearby devices, we can send out pings to the other devices, to these devices, whether they're in discovery mode or not, to see whether they are in reach. Let us know whether this lets us know whether they are active and within range. To send a ping, we use L2 ping command with the following syntax. This output indicates that the device with the MAC address is within range and reachable. This is useful knowledge because we must know whether a device is reachable before we even contemplate hacking it. Okay, so from what I can see and understand, for both Wi-Fi and Bluetooth hacking, for educational purposes, we are not hacking to steal anything. We are not hacking to compromise anybody. We are just hacking to learn from it. It's a good thing to learn because learning is good. I could learn how to hack, and then I could share that knowledge. And everyone can understand themselves in which ways they could be hacked, and then they could understand. They could come up with ways to make themselves safe from being hacked. That's the purpose of this. So, as in summary, wireless devices represent the future of connectivity and hacking. Linux has developed specialized commands for scanning and connecting to Wi-Fi APs in the first step toward hacking those systems. The air cracking suite of wireless hacking tools include both AirMong and air dumping, which enables us to scan and gather key information from in-range wireless devices. The Blues suite includes AirSlan and the other tools capable of scanning and information gathering, which are necessary for hacking the Bluetooth devices within range. Also include many other tools worth exploring. All right, guys. So that would be it for today. That will be it for chapter 14. And now, before we move to chapter 15, they want us to do these, but as you see, we cannot do any of these because, due to us not having Wi-Fi Wi-Fi tool or devices, NIC on our interfaces, sorry, Wi-Fi or wireless interfaces on our motherboard, on our device. We cannot do none of this, but I will make sure to take my laptop and do all of this, test all of this, and if it's possible, I will make a video about it and post it. And if you want to see that video, make sure you're subscribed to the channel. Turn on the post notification so you can be able to see the video when I drop them. And so after we're done reading all the chapters in this book, next time we're doing chapter 15, which is managing the Linux kernel and loadable kernel modules. So after we do that, we will go in section in each chapters. We will look for books that dive deep into those what are they, into those sections, so that we can dive deep into them and understand them even more, like bash scripting, you know, what we just did right now using the blues, you know, hacking Wi-Fi and hacking Bluetooth devices, you know, logging and everything else, you know, all the good things. So I thank you for joining me on this stream, and I hope I can see you next time. I hope you enjoy, you join again next time. As it, that will be it for today, and I will see you all next time. So have a good day, have a good night, and you know, let's do goods to the world. You know, let's spread the goodness of everything, the goodness of God, the goodness of food, and hacking.